My job takes me around the world. The more I travel to industrialized cities, the more I notice how common air pollution is. When you factor in the rise in smoking, it's easy to see why lung cancer is such a growing problem. And that's why medical startup 12 Sigma decided to tackle this challenge. I'm Arjun Dutt with NVIDIA, and this is IMAI.
Lung cancer is the most deadly cancer. The 5-year survival rate is only 17%. This is all over the world, in China, in US, in Japan. The reason for that is when doctors diagnose people with lung cancer, it's already in the mid or late stage.
When diagnosing lung cancer, doctors look for small nodules in the lungs. But these are not always easy to spot.
So almost every single lung cancer started as a smaller nodule. Lung nodules have a big variety of looks. And it takes a doctor years to know all these different looks.
Doctors are very good at finding large size of non-nodules, such as 6 millimeter or 10 millimeter. But when looking at smaller size nodules, such as 4 millimeter, sometimes they have difficulty.
And that's what we were trying to solve, is to help doctors to detect these lung nodules early before they turn deadly.
Saving someone's life is meaningful, and this is exactly, what we are excited about.
That's why 12 Sigma started looking at deep learning to develop an artificial intelligence that could help doctors identify early signs of cancer.
We think AI is suited for detecting cancers because there has been a vast amount of data being produced, and also because the advances of computing power. We can use the latest deep learning and computer vision technology to process this data. For lung cancer, we use CT images from many hospitals in the US and China. Differently from the 2D images that people are seeing in ImageNet or face recognition, the CT scan, it's a 3D volume. So one CT scan consists of probably 300 to 500 images. We use convolutional neural network that instead of manually defining the visual features, will learn these features automatically through what we call supervised learning process.
What they're actually using is a 3D convolutional neural network, or CNN. In a typical 2D trained CNN, a convolutional layer processes an input image with a set of learned filters. Each filter produces an activation map that is typically positive where the filter matches the image and negative where it doesn't. These maps then pass through an activation layer to strengthen the signal and a pooling layer to reduce the data and maintain its most essential components. The process is repeated many times, and the resulting data is used to classify objects in the image. When working with volumetric data, such as a CT scan, the process is similar, but extended into the third dimension. Evaluating three-dimensional structures is essential to identifying possible tumors.
GPUs are very important for neural network training. NVIDIA has the most advanced GPU that has improved the computational speed for neural network more than 50 times over CPU. So this helped our computers to learn models faster, and we can reduce training time from weeks or months into days or even hours.
Having an AI read and interpret CT scans may sound like science fiction, but 12 Sigma has already begun testing their system in several hospitals.
Doctors have this kind of feeling. AI is 20 years away. They didn't expect it's actually here, so close already.
In China, we are putting our products in about 35 to 40 hospitals already. Most of the doctors, they are using their naked eye to look at the images first so that they are meeting all the regulation requirements. Then they're using our system as a second reader to look at the image again. In many examples, they have found more nodules that they haven't found.
有一个病例就是我自己看到了病人有3个肺癌，小的结节我让计算机去跑，当它显示出4个的时候，我很震惊。如果是手术，最好一次4个都处理掉。如果没有看到第4个的话，病人要经过2次手术。
The AI's precision is impressive, but how do its diagnostic capabilities stack up to an experienced radiologist?
we actually do have some false positives or false negatives. And the doctor will remove these false positives and add the false negatives. We can learn again, we can fine-tune again using all this newly labeled data.
By working with the doctor and software together, we can achieve very high sensitivity and very low false positive.
It took a doctor 8 to 10 minutes to look through a CT scan. This is without determining if it's benign or malignant. Now our system, it took us 2 minutes to complete the detection and also the classification. So actually cut the doctor's reading time by 4.5 hours on an average day.
One of the main things for all software is save doctors' time.
And have the doctors to focus on more important things like research and communicating with patients.